Malaysia has worked in conjunction with the Australian Transport Safety Bureau to coordinate the analysis, which has also involved the UK's Air Accidents Investigation Branch, Inmarsat, and US National Transportation Safety Board, among others. Others have also made efforts to analyze the satellite communications, albeit challenged by a lack of publicly available information for several months after the disappearance. During flight, the aircraft maintains a data link with a satellite communication network for data and telephone calls. The data link connects the aircraft and a ground station via satellite, which translates, changes, the signal's frequency and amplifies the signal. The ground station is connected to telecommunication networks, which allows messages to be sent to and received from other locations, such as the airline's operations center. Between the 2:25 message and 8:19, the SDU acknowledged 2 ground-to-aircraft telephone calls, which were not answered, and responded to automated, hourly requests from the ground station that were made to determine whether the SDU was still active. The aircraft's final transmission at 8:19 was a log-on message. The aircraft did not respond to a message from the ground station at 9:15. Investigators believe the 8:19 log-on message was made when the SDU was restarting after the aircraft ran out of fuel and the aircraft's auxiliary power unit was started. The search for Flight 370 was launched in Southeast Asia near the location of the last verbal and radar contact with air traffic control. Relatively simple calculations can be made from BTO values to determine the distance between the aircraft and satellite at each transmission. When these distances are plotted on Earth, they result in rings which are further reduced to arcs, due to the limited range of the aircraft. Initial analysis of the BFO values showed a strong correlation with a track south into the southern Indian Ocean, west of Australia. After the initial analysis, the BFO calculations were later adjusted to account for a wobble in the satellite's orbit and thermal changes in the satellite which affected the recorded BFO values. Further analysis considered the BTO and BFO calculations with flight dynamics, such as possible and probable aircraft speeds, altitudes, and autopilot modes.